I'm going to do the Euclidean algorithm for greatest common divisors. Now, I'm going to do two columns, and only one is what you would have to actually show for your answer. But one of them is like where our answers come from. So if we look at our work, the way you actually do the Euclidean algorithm is you always divide the big number by the small number. So 213 divided by 117, it goes into it once, and then you subtract to find the remainder. When you subtract these, you have to borrow and stuff, but you get a remainder of 96. So this is what you do. You say that 213 is equal to 117 times 1 plus 96, and here's where all those pieces came from. This is your dividend, the thing you're dividing by. This is so 117 is your divisor. That's what it came from. The 1 came from, that's the quotient. And the 96 came because that's the remainder. If you want, you can put 1 remainder 96 here if you want, but it's just obvious that it's a remainder right here. And then you just keep going, but you do it with the next numbers. So we already did with the 13. So now the next numbers, we don't care about the quotient. We just look at the big and small number between these two. So the remainder always has to be less than the divisor. So you always take what that remainder was and divide it by the previous divisor, and you just keep going until you get a remainder of 0. When you get a remainder of 0, you'll know that you have your last divisor was a greatest common divisor. So we divide this into it. This goes into it once. Bring the 96 here. Subtract 96 from 117. 7 minus 6 is 1. 11 minus 9 is 2. So it's a remainder of 21. And so we write it like we did before. The 117 goes first, equals, the divisor was 96, the quotient was 1, the remainder was 21, and we got to keep going because we don't have a remainder of 0. So divide 96 by 21. And so when you divide, 21 goes into 96 4 times. You get it. You get our 84 here, remainder of 12, and so you rewrite those elements just like we did before. So we put the big number we divided by equals 21, which is the divisor. And then the quotient, that doesn't really matter, but it went to it 4 times, plus, and then 12 was the remainder. We don't get a remainder of 0, so now you divide 21 by 12. 21 goes into 12 once with a remainder of 9, so we do 21 equals 12 times 1 plus a remainder of 9. We don't get a remainder of 0, so now we have to divide 9 into 12. So let's do 12 divided by 9. 9 goes into that once. Remainder of 3. So that means that 12 is equal to 9 times 1 plus a remainder of 3. Don't get a remainder of 0, so you have to go again. So now we're going to divide 9 by 3. So I'm going to divide 9 by 3. 3 goes into 9 3 times. Remainder of 0. Yay! Remainder of 0. And our last, we did that by dividing by 3, and we got a remainder of 0. So that means that, and let's write the linear combination just for the formality. 9 is equal to 3, that's this 3 right here, times 3, that's the divisor 3, plus the 0, and since our most recent divisor was the 3 right here, like that's where that 3 comes from, that means that your GCD is going to be, so that means your GCD is equal to 3, and specifically your GCD of 117 and 213 are equal to 3. That's it. And you could also, I chose to look at it from here. You could also see it is the last non-zero remainder. That's cool too, but it's also the last divisor that got you a remainder of 0. And that's how you do the Euclidean algorithm here.